Day 17 of solving math problems in C until NVIDIA hires me. So we're first told that a perfect number is a number for which the sum of its proper divisors is exactly equal to that number. So for example, the sum of the proper divisors of 28 is 28. So 28 is a perfect number. And if that sum is smaller than that number, then it's deficient. And if the sum is larger than that number, then it's abundant. Then we're told that 12 is the smallest abundant number and 24 is the smallest number that can be written as the sum of two abundant numbers. And every number greater than 28,123 can be written as the sum of two abundant numbers. And our goal is to find the sum of all the positive integers which cannot be written as the sum of two abundant numbers. So solving this problem is very simple. We'll first find every abundant number and store it in an array, and then loop through every pair of abundant numbers we found and sum them and store that in an array. And then every number up to 28,123 that's not in the array we found in step 2, we'll sum it up. With that in mind, let's get to coding. First, I'll include the standard IO library. Then I'll include the standard lib library. Then I'll define n to be 28,123. Now we'll create a function called isABD, short for abundant, that takes an integer x, and initialize a variable sum to 1. We're summing the proper divisors of a number, and every number has a divisor of 1, so we're guaranteed to be adding 1 to our sum. Now we'll say for int I is equal to 2, I times I is smaller than or equal to x, I plus plus, and we'll check if x mod I is equal to 0, then we'll say sum plus equals I. And if I is not the square root of x, then we'll add x divided by I to our sum. Lastly, we'll return sum is greater than x. And this function will tell us if a number is abundant or not. Now in our main function, we'll write int pointer a is equal to int pointer and call c alloc with the arguments n and size of int. And this will initialize an array of all zeros of the size 28,123 in the heap. Then we'll say for int I is equal to 12, I is smaller than n, I plus plus, and we'll set a of I equal to the return of isADB of I. Now we'll create a new array using int pointer c is equal to int pointer and call c alloc with the arguments n plus 1 and size of int. Now we'll loop through all the pairs of abundant numbers using for int I is equal to 12, I is smaller than or equal to n, I plus plus, and we'll check if I is abundant. Then we'll say for int j is equal to 12, j is smaller than or equal to I, and j plus I is smaller than or equal to n, j plus plus, and we'll check if j is abundant. Then we'll set c at I plus j to 1. Now we'll initialize an integer sum to 0, and we'll say for int I is equal to 1, I is smaller than or equal to n, I plus plus, and we'll check if not c of I, meaning that I is not the sum of two abundant numbers. Then we'll say sum plus equals I. Lastly, we can print out the sum, free our A array, and free our C array. Then we compile and run our file, and we got 4,179,871. Let's check if it's correct. And our answer was correct, guys. See you in day 18.